All right, so we're starting chapter 6, and we start seeing some applications of integration. And the first application is very, very powerful, and it looks like it should be complicated given how complicated things have been in the past. But in reality, it's actually very nice and simple to a degree. And the idea is this: we would like to find the area between two curves. Now, what we've done in the past is we've had a curve and we've wanted to find the area between the curve and the x-axis. All right, and so we've talked quite a bit about how that is done to find this area here. But what we want to do now in this section is look at the process for having two curves. All right, having two curves, f and g, or we'll talk about this case over here in a second, but two curves, and we want to find the area between them. So again, we run from A to B, and we want to find the area in between. Now, what's great about this is if we can find this area, then we can find areas of much more complicated shapes than we could when we were just finding the area between a curve and the x-axis, right? We can get shapes that are bounded on both sides, above and below, um, and that gives us way more ability to find really complicated areas. Now, looking over here, the idea is the same, except we've moved instead of to an above below model. We're now finding the area between curves where the curves are left and right of each other. All right. So we're trying to find the area again. Let's just call this from C to D, and we're trying to find the area between these curves. But these curves happen to have a kind of a horizontal relationship to each other. Um, but either way, the process is uh, pretty straightforward, and it's actually simpler than you would think. Um, so here is the idea. So if we're looking at the situation where, let's look at this first case right here, where we have an integral or a function that's on what we'd call the top function and what we call the bottom function. If I want to find the area in between them, all I do is I integrate the top function minus the bottom function, and this will be a dx integral. So in other words, these will be, our limits will be on the x-axis. All right? So you just take the top function minus the bottom function, and then you try to integrate that. Now, whether you can integrate it or not is a different question, but at least as far as setting it up, it's fairly straightforward. Top minus bottom. Now, let me mention this case where we're side by side over here. What changes here is now, I should mention, let me write this other one more time. So we integrate a to b, we integrate the f of x minus g of x dx. Okay. Now, if we're doing this sideways, right, basically what we do is we integrate from c to d, but we do right minus left function. And this will be a dy integral. Our limits will be on the y-axis. Or to be a little more precise, we would take g, which is a function of y. That's the difference, is in this sideways situation, we need our functions to be functions of y instead of functions of x, minus f of y dy integrated from c to d. All right. So that's how we set these up. So it's actually very, very powerful if we can, so we can set these things up and we can find these integrals. As long as we can evaluate them, we can find these areas. So let's look at an example. So typically what you'll see is you'll see problems that say something like this. Find the area between, say, y, or let's go this way. Let's go f of x, between f of x equals x squared minus 3 and g of x equals negative x squared plus 2. All right, and that's what they'll say. They'll write it out like that. And the first thing you got to do is you got to realize you're going to need a graph, right? You really need to graph these things. So you can graph these functions on Desmos. These are simple enough that we can probably just sketch them in here. X squared minus 3 is going to look like this, right? It's our good old parabola down here, shifted down 3. Negative x squared plus 2 is the upside down parabola shifted up 2. And so once you see the graph, you're clearly able to see the area that is between them. Now you might argue, well, what about this area? This area is between. This area is between. Really what we want is we want this enclosed area right there. Now if it's unclear, they'll usually give you enough clear directions so that you don't have to worry about it. But we can see here that we want this area, this odd little shape area here. And so this is a situation where we've got a top and a bottom kind of function. And so when we set up our integral, we're going to take the top minus the bottom. Now, but I guess before we do that, we actually need to figure out what these, this should all be symmetric, what these limits are, right? How wide we're going to have to go. And so in this case, the way we will do that is we simply need to know when does the one function equal the other function, right? If you set them equal to each other, you find the intersection points. And so this gives us minus 2x squared equals minus 5, or x squared equals 5 halves, which gives us x equals plus or minus. So all we got to do is take the square root of 5 halves, which is plus or minus. Let's fill that in our calculator. We'll just call it 1.6. It's actually 1.58. But that's important because you need that information to figure out your limits. So we're going to integrate from negative 1.6 to 1.6, and we're going to do the top function, which is, again, this is why we rely on the graph so that we can clearly identify top minus bottom. And notice how I'm putting this second function in parentheses so that the signs all work out. And so now setting up these problems is easy, usually, because you just do top minus bottom. And then you've got to figure out a way to integrate them. This one's not going to be too bad. So I'll just put this on pause and integrate it real quick. All right, so there it is. There's our answer. I've rounded a little bit, but you can see the work done there. All right, so there are a couple tricks that you'll want to be aware of in this situation. I'll put up another example with a couple more, or another video with a couple more examples, but this should get you started on this process.